Okay, folks, Le Châtelier's principle is something that you're really going to have to take your time with. It's something that used to be taught to A-level, but it's now on the GCSE specification and is usually pitched towards the grade 9 level. My advice would be possibly to copy that down first, pause the video, copy it down, and then listen to it and annotate notes afterwards. But you do what you want. All I'd say is have a look around at Bite Size, have a look around at different websites that you might be comfortable with, and supplement your notes as I go through this. Right, so I'm looking at Le Châtelier's principle. On the previous video, I discussed reversible reactions, and this is where you've got A plus B as your reactants, can go to C plus D, your products, and vice versa, so your products can be turned back into your reactants. And I've said that it reaches a system of equilibrium in a closed system. That is where A plus B makes C plus D, and C plus D makes A plus B at the same time. Right, okay. Chemists, once they have got it into a closed system situation, can manipulate the equilibrium to produce more or less of a product or a reactant. Okay, and this is how we do it. Okay, so let's have a look at how concentration affects equilibrium first. So here we've got bromine as a liquid form reacting with water in a liquid form, and that produces two hydrogen ions, okay, which are aqueous, bromine as a negative ion, which is aqueous, and bromine oxide, which is also aqueous. Right, okay, now the thing is with Le Châtelier's principle is whatever you try to do to that closed system, the chemical reactions will try to do the opposite, or it will do the opposite. There's no try about it, it will do the opposite. So it counteracts any change that you try to make, and this is how chemists manipulate the chemicals in this. So, okay, look at this here. If I add more hydrogen ions into the system, okay, what's going to happen is it's going to start producing more reactants to counteract that change that I've done. So if I chuck in more hydrogen ions, then we end up more of this. So if we add hydrogen ions in to counteract it, it favours the side without the positive hydrogen ions. Chemists would say that the equilibrium has shifted to the left. In this example, it's shifted to the left. So more of your reactants end up being made if you chuck in more hydrogen ions. Okay. On the other hand, if you take some hydrogen ions out, so you lower the amount of hydrogen ions, then it'll start reproducing more of this in order to counteract that change. So if you reduce the amount of hydrogen ions, then it'll start making more products. We say it favours the side with the hydrogen ions in this instance. Okay, so equilibrium has shifted to the right in that example. Okay, let's have a look at a different example. Instead of concentration, now let's have a look at temperature. So if we've got dinitrogen tetroxide as a gas, okay, and we've got it in a closed system, what happens is it will turn into a brown gas, which is nitrogen dioxide. Okay, now in the forward direction, that's endothermic. Okay, in the reverse direction, that's exothermic. Right, if I increase the temperature of that system, okay, it's going to start making more brown gas because you've got that cold reaction where it's endothermic. Okay, so to counteract the increase in temperature, it's going to produce more brown gas. So that what you see in your closed system is you start to see brown gas instead. If you then cool that system down, okay, and do the reverse, it's going to favour that exothermic side, and then the gas is going to start looking more colourless rather than brown. So if you increase the temperature, it favours the endothermic side. If you decrease the temperature, it favours the exothermic side. So in this example, it shifts to the right if you increase the temperature, and it shifts to the left if you decrease the temperature. Now watch out, it won't always be the same way. You have to analyse your equation and you have to have a look because the endo and the exo might not necessarily be that way around. Finally, we know that in terms of pressure, if you increase the pressure, then you're increasing the amount of particle collisions. So here, I've got two lots of sulfur dioxide as a gas, and I've got oxygen as a gas there. Okay, that forms a reversible reaction with sulfur trioxide, which is also a gas. Right, on the left, I've got two lots of sulfur dioxide, and I've got one lot of oxygen. So I've got 3 moles on the left-hand side, which is my reactants. On the right-hand side, I've got 2 moles of sulfur trioxide. Okay, so there's 2 moles. So more moles are on this side, less moles are on this side. If you increase the pressure of your closed system, if you increase the pressure of your closed system, okay, that's going to favour the side with less moles. Okay, so if the pressure goes up, it's going to increase that side to try to counteract. Okay, so if pressure increases, it favours the side with less moles. On the other hand, okay, if you decrease the pressure, so if the pressure goes down, it's going to favour the side with more moles, and that is something that you're going to have to learn. Okay, so in this example, if you increase the pressure, okay, it will shift the equilibrium to the right, and if you decrease the pressure, it shifts the equilibrium to the left. Final thing to do with Le Châtelier's principle, okay, look at catalysts, okay, catalysts do not shift the sides to the left or the right, the equilibrium does not change. The reason why we use catalysts in dynamic equilibrium is because it allows you to get to equilibrium point quicker. Okay, this, what some would argue, is probably the most in-depth you get in biology, chemistry and physics GCSE. Okay, don't take this lightly, look at it, watch the video several times, okay, and take notes from various different sources. There are plenty out. Khan's Academy do a good video on it. Alright, all the best.